So I just wanted to take a moment to show you all what I've been working on recently. So over my winter break, I spent quite a lot of time and effort and sanity building this light board. So what this is a large piece of acrylic glass stuck in between some 2x4s. And in the trench along the edges, you can probably see it, there are LED light strips to illuminate the board. I then use window markers to write on the board with a black backdrop for you to be able to see the writing. Now I have a studio mic above and my Sony camera as the main camera looking at the board. I also have two studio lights in the background, which is where I stand to illuminate my face while writing on the board. My marker tray and stuff is here as well. And I don't write backwards the entire time, I just flip the video in my computer. So this here is the computer I use to stream. On my computer, I have OBS running, which allows me to toggle between different cameras and things like that. I also have an Elgato Stream Deck, which allows me to control all of that. I also have this Wacom tablet, which is allowing me to write and display my notes. So I, in addition to those, have a camera over here. This is my other cell phone. I use this as a wireless camera for any demos that I would like to show in my videos. So if I want to use all this, what I can do is, right now I have OBS displaying my notes, but let's say I finish giving a lecture and I want to show a demo that proves it. So I'll come over to here, hit phone camera, and when I hit it, it transitions over to the camera here. And then let's say I'm done with that, and now I want to show you some math, so I can hit Lightboard, and that takes us over to the Sony camera, where you can maybe see I'm waving my hand in front of the camera here. I can also use this to control my different microphones as I go. So this is just a really great setup where I have my notes being displayed, a station for doing demos, as well as the Lightboard for math and other things with my face. So why don't I go ahead and swap over and show you what this all looks like. All right, so let me just give you a very quick demo of what I can do with this entire setup. On the screen, you have a sample lecture. The actual contents do not matter, but let's just say I'm giving a lecture. So in the image on the right, up top, you see a circuit of a battery connected to a single light bulb. On the bottom, you have two light bulbs connected to that circuit, and they're wired in series, meaning they are connected directly end to end with no additional paths. When connecting light bulbs in series like that, you're increasing the amount of resistance in the circuit, meaning the current through the light bulbs decreases. In other words, when you connect the light bulbs in series, they should be dimmer. So let me go ahead and swap over to my phone camera and show you proof of this. So here we have a little circuit board where you have batteries on the left and a light bulb being illuminated here. It's a single light bulb connected to the battery. So note its brightness. Let me now connect a second light bulb in series with this one. And we will make note of the brightness of these bulbs in just a moment. Okay, so it might be kind of hard to see, but there they are. So there are your two light bulbs illuminated, but dimmer than when it was a single light bulb, thus proving the increased resistance decreases the overall brightness of the bulbs. Okay, so at this point, let's return to our notes. So now let's say I want to work on an example. This example here says what is the current in the circuit that is shown. Again, I'm going to start writing things here, but the context of them does not matter. We aren't expected to know this stuff right now. This is just a demonstration. So let's hop over to the Lightboard. Okay, so now what we want to do is try to solve this particular problem. I kept the picture in the upper right so that you can still reference the image as we try to solve this. So going forward, what we want to do is set up something that we call the loop law. What the loop law says in circuits is that the total potential difference around a loop, in other words, delta V, we'll say subscript loop, the potential difference should equal 0. So in this case, we have 4 different elements in the circuit. You see the 2 batteries on the left and the right. You also see a resistor on the top and the bottom. 4 total elements, in other words, 4 things to write in our equation. We have the EMF of the first battery minus the potential difference across the first resistor, we'll say resistor R1, minus the EMF of the second battery, and then minus the potential difference across the second resistor. Now, by definition, the loop law tells us that the overall potential difference around a closed loop should equal 0. So in this case, we now have established an equation that if this was a full lecture, I would go through and solve. In this case, if I remember correctly, the current overall, once you solve this, should come out to be 0.05 amps. And there you have it. So I constructed this Lightboard for a couple of reasons. One, I mean, it's just pretty cool. But 2, I wanted to make my online content a little bit more personable, right? Rather than me just talking over my PowerPoint slides, I now have the ability to directly engage with you through the video. Furthermore, I'm going to use this to just start creating more content and better content as we move forward. So I'm very much looking forward to creating new content and better content for you guys, both as my students or just people on YouTube. I love doing this, and I hope you enjoy this setup. This is the very early version of this setup. I just finished building it. So if you have any questions or comments or tips or anything you want to see, let me know, and we'll work through that. But until next time, see you soon.